Myself Servan Kumar, Faculty of ACE Engineering Academy. Let me go through this tsgenco EEE. Okay, so most of the students who have already completed their study for EEE tsgenco, some topics are newly added to them. Okay, so one of the topic that is added is communication systems. Actually, the syllabus not only in electrical branch, even in electronics branch, civil branch, mechanical branch, whatever the topics that are there actually in engineering studies, engineering examination, UPSC engineering services examination, the syllabus is given in GENCO papers. To be frank with you, it is quite a lot of syllabus. Okay, so today I am going to cover what should be your preparation strategy for AE EEE examination related with the communication area. So that part I will cover today. Okay, so this is the preparation strategy for communication subject. Okay, so those students who have already completed their study, now it is a time for you to think about the new topics that are included in your syllabus. And most of the students, they may think that they can leave these things and go. This is not just a competitive exam, it is a competitive exam for giving you job. So don't think that examiner don't give questions from these newly added topics, or he may not give tough questions from this area. All areas has to be treated equally. So don't leave anything, because questions are going to come anywhere from your syllabus. Syllabus is very huge, we cannot do anything for that. So try to keep as much time as possible and try to master your preparation in all the subjects to the maximum extent, because your score is not only going to determine your rank, your posting of location also. So try to be very effective in this preparation. Okay. So here these are the topics that were included. First let me discuss what you have to study. Okay, and then we will see some questions related with this area. So these are the things that I am going to tell you now. So what topics you have to prepare, how much time that you can spend, and what are the important areas that you have to focus. Some questions related with this particular area. So that will conclude my discussion today. Right? Now see here, when you have this communication subject, the fundamentals of signals is very important. So it does not mean that you need to know everything related with the signals and systems. That is not required. Requirement is fundamental signals. What is basic signals we have and what are their transformations. So that is the first part you have to cover. So basic signals and their transforms. Fundamental concepts only, don't go in depth. Okay. What are the minimum requirement things that you need to know. So these are the first part. Next, what is the block diagram representation of an analog communication system? So they very clearly mentioned in your syllabus, starting with the communication system fundamentals. So what is an analog communication system? What blocks it is having? And what are the parameters that you measure at each and every block? So that is the block diagram representation. Now, coming to different modulation schemes, your study will start from the third topic. So first two are like fundamental things. Coming to the different types of modulation schemes, we are having a standard amplitude modulation scheme. Then we have DSB-SC modulation scheme. This is double sideband suppressed carrier. Then SSB-SC, single sideband suppressed carrier. So these three modulation schemes comes under amplitude modulation scheme. Then we have frequency and phase modulation schemes. They come under angle modulation schemes. And these are completely formula based. That means whatever you study, just let me write it here. So you have different modulation schemes. So we are saying that the modulation scheme is S of t. Let us consider this is your modulated signal, which I am representing as S of t. Okay. Now on each and every modulation scheme, you need to know what is the total power requirements, PT, and you need to know what is the spectrum, and you need to know what are the bandwidth requirements, and then we need to know what is modulation efficiency. So based on your modulated signal S of t on a given modulation scheme, we will be having these parameters. So all these questions which are coming in your examination will be from these areas only. So each and every modulation scheme have their fundamental questions. Like we are discussing amplitude modulation. So on amplitude modulation, all these points you should know. Then what is double sideband suppressed carrier? On this you should know all these points. Then what is SSBSC? And on this you should know all these points. Then frequency modulation and phase modulation, finish. So these are the areas that you need to focus on. That will be sufficient. So whatever you are learning here, these should be formula based. So don't try to analyze and do big questions now. That is all not required. Because what are the questions you are going to get are time based. Maximum time you need to spend is 60 seconds, maybe less than a minute. So don't try to do big things in this area. Refer fundamental formulas. So whatever every modulation scheme you are studying will have its standard equation, and based on that you will have all these calculations: power, spectrum, bandwidth and modulation efficiency. So these things if you do, that will be sufficient enough. So your preparation should be in this model. Don't try to refer big textbooks, so much of time don't try to spend on this, because you need to revise whatever you have studied and these new topics also. So try to give equal importance to these areas. Now that is what these 4 parts, this is all analog communication schemes. Okay. Now he has also mentioned about noise in your syllabus. So noise means it is a very big topic, to be frank. It is a very huge topic. But keeping in mind that you belong to electrical branch, the noise model questions will be very fundamental. So basically what is this additive white Gaussian noise, AWGN? How you are calculating a power of noise at the output of receivers. Only those points are enough for us. So this is a very big area, but what is required, only that part you have to concentrate. Okay. Now once we are done with this, then we are having different types of receivers. AM receivers as well as FM receivers with standard parameters. So you have to remember those values and 1 or 2 questions related with that area. So they have mentioned receivers also clearly in the syllabus. So this is also there. Now all this part up to this is almost analog communication. But from here it is about digital communication. So how you are transmitting your data using binary format, that comes under digital communication. So what blocks you have? You will have sampler, you will have quantizer, you will have encoder. So those are also clearly mentioned in your syllabus. So what are those blocks doing and what are the formulas related with those blocks? That we will discuss in this area. So the modulation scheme related with that is pulse code modulation. And this topic of pulse code modulation is completely formula oriented. So whatever this part we are having is analog. Okay. Now once we complete this part, then we will have digital. So in digital communication, they have very clearly mentioned very limited syllabus. So what is the process of sampling? That means what is meaning of sampling and what is the sampling frequency you have to follow. Then what is the meaning of quantization and what are the parameters related with it. And what is bitrate requirements and what are bandwidth requirements. So these are the areas that we need to focus on. So all these are completely formula based. Okay, so that is the reason these things you have to keep in mind, the formulas based on the data given to you, apply it directly. So these are the areas where plenty of numericals can be framed. So it is one way a very difficult task, but the other way you can score, because most of the questions coming from communication, that too it is first time coming in electrical paper. So whatever the questions you are getting might be neutral level or maybe little bit tougher. Don't assume to be very easy, maybe neutral. That is what I feel. So those questions you can score also. So that is the reason don't leave anything on this part. So this is your analog part and digital part. Finally, they have also mentioned multiplexing schemes. FDM we use in analog techniques and TDM we use in digital techniques. So frequency division multiplexing, how we are applying in analog communication, and time division multiplexing, how we are applying in digital communication. So these are the areas that you need to focus on. So syllabus I have very clearly mentioned topic by topic, whatever that is given to you in your notification. So don't go anything above this. If you want to refer any standard textbooks, you can refer, but you have very limited time. So don't try to focus more on these newly added areas. Focus in such a way that you are spending minimum time to the maximum benefit. Okay? So these are the areas that will be covered in communication part of electrical branch. Okay? Now, what do you have to do? What should be the preparation strategy? So this communication part is given in analog and digital electronics. If you see your notification under syllabus, in this analog and digital electronics, half of the syllabus is communication. So when examiner sets these questions, normally what happens in objective papers, they have to give priority to all the areas because they are mentioning the syllabus. They cannot straight away remove one complete unit from the syllabus and frame the paper. That will not happen. So what they will do is, every topic they will pick questions. So if they refer to this analog and digital electronics part, so you are having a analog part, the digital part in the sense not digital communication, your flip-flops, memories, little bit of that is also there. Along with this communication is added. So depending on the number of questions you are getting from this total area, a little bit of weightage is given to communication. So at least 50% of the total questions coming from analog and digital electronics will be definitely from communication. That part we can tell. So if you assume some 7-8 questions coming from this total part, at least 3 to 4 questions you can assume coming from communications. Okay? So my expectation is you may get around 3 to 4 questions. That is what I am thinking. Okay? So generally if we see the syllabus weightage and the way how they have divided the syllabus, because the syllabus is completely UPSC engineering services syllabus. So when you refer to engineering services paper, objective paper, they will give weightage for all the topics. That is a strong rule. They will not eliminate any part. But the questions framed will be average level only. They will not give very tough questions because they are all time bounded questions. You have to solve the question within a minute, not more than that. So that is the reason questions will be at average level only. They will not be very, very tough questions. So that is the reason whatever the questions you are getting on this will be relatively easy or average, neutral level. But maximum you can expect 4 questions. That is what I am thinking. Okay. Now, from where these questions are going to come? So already I have listed all the topics. So whatever that is there in the communication part of your syllabus, I have divided into signals part, communication analog and communication digital. So from this fundamental area you can expect one bit. That means what are basic signals, like we have impulse, we have step, these basic signal properties and the Fourier transforms of those signals along with the sampling technique. So the highest weightage topics that can come from here is transformation and sampling. So one question you can expect from this area. So this is actually the basics of your signals and systems because the extension of that subject is communication. So without knowing these fundamentals, you cannot cover these topics also. So that is the reason this should be the primary focus. So we can spend around some 3 hours on this particular area. Okay. Now, 3 hours means whatever I am explaining, means as a teacher I can explain the fundamentals required for you in 3 hours. You may require more time. That depends on student to student. But as a teacher, when I am explaining to my students, this is the time that I am allocating for that particular subject. Now, coming to communication systems, if you take the analog part, already I told you different modulation schemes are AM, DSB, SSB, FM and PM. So totally we are having here 5 modulation schemes. So your question coming from here can be anywhere on these 5 modulation schemes. So one question we are expecting from this area, and from here you may get 2 questions. So those questions also from where mostly expected, one from amplitude modulation schemes, that means it can be AM, it can be DSB or it can be SSB, and one question from FM and PM. So that is the reason I have mentioned here clearly from which topic also that question is chance. So you are having a bandwidth power, narrowband and wideband FM in FM modulation schemes, and bandwidth requirements for multiplexed signals. That FDM concept is there, na? That is also coming from this area. So this is where you need to prepare for 2 questions. Okay. Now, coming to the last part, digital communication systems. From here also you can expect 2 questions. So here the topic is very clear. It is pulse code modulation. So what are the bitrate requirements? What are the bandwidth requirements? That part will be the main area. So these things if you study, then that would be sufficient. So maximum, as per my expectation, you can get around 4 to 5 questions. 1 question from the fundamental area, 2 questions from communications analog part, and 2 questions from communication digital part. So the time I am allocating here is 3 hours for fundamentals, 5 hours for analog and 5 hours for digital. So whatever the things that I am going to cover will be on these areas. Okay. So those students who have already having knowledge on these things and fundamentals of signals, if you are clear, then definitely these topics are going to become easier. But once again I am repeating, strictly you go with the formula based questions. Don't go into too much big like gate oriented models. That model of questions definitely there is no chance of asking in this exam. It will be relatively easier, or neutral model questions. Definitely they will not be tough. That much I can give guarantee. Okay. So maximum you can expect around 4 to 5 bits. Is it clear? I hope the syllabus is clear. First is to get the hold on syllabus. Okay. And don't try to spend 30-40 hours on this topic. Relatively 15 to 20 hours, that would be sufficient. Ideal is 15 hours. Maybe if you are an average student, little bit more, so go with 20 hours, not more than that. Is it clear? So please go with these topics. I have divided the entire syllabus into 11 topics. Only these topics particularly you prepare. And if you want questions for reference, you take this UPSC paper questions. Actually don't take the total questions. Take the questions which are relatively formula based and go through last 3-4 years papers. Don't go more than that. So EC branch has this communication, as well as electrical branch also has this communication in engineering services examination of UPSC. So there you refer the questions given on these topics, because those questions are also completely formula based. So for an examiner who is setting the paper, that will be the reference. So mostly they will look into those questions and might give the same models coming in those type of examinations. That is the reason your reference for practice will be these UPSC papers coming for engineering services examination. Don't take too much long, maybe 3 or 4 question papers are sufficient enough. So because you primarily belonging to electrical branch, you can refer electrical paper objective where this communication syllabus is added, and refer only to formula based questions. Don't go through all the questions and break your head. So that is the best way you can cover the syllabus in very good time. Okay, spend 15 to 20, maximum is 20 hours, not more than that. Is it clear? So I hope all these points are clear. Any doubt you have, you can just type. I am online. If anything is required, I'll just cover those points. Okay? Is it clear? Because most of the students who have already taken coaching with us, they are also requesting to cover these extra topics that are added. So I am planning to cover those topics maybe in quick time. The schedule is yet to be released. Mostly it will be coming in the next week. So those students who wants to enroll for that program, you can just visit our academy or make a call. They will definitely guide you through the correct process. Okay. So because this is all first time introduced, questions will be simple only. They will not be too big, formula based. So I am also not taking much time to cover. Maybe 10 to 15 hours is the maximum duration that I will take. So whatever the formulas that you require, all those things we will be preparing a simple material. You can refer that material for formulas as well as for practice purpose. That will be sufficient enough, because whatever the questions we are covering now, I have already filtered the questions from these ESC papers, whatever that is required. Only that part I will be covering. And it should be covered in a quick time. If you take now, like 30, 40 hours, I can explain things and very nicely, but there will be no use for you because you need to concentrate on other subjects. And basically the notification has come out, so you don't have much time for examination also. So smart preparation at this instant is required. So those candidates who are interested to cover this topic, please log on to our website. You can get the phone numbers, you can call us, or those who are staying in Hyderabad, you can directly meet us at the academy. They will guide you to the process. Okay. Hope these points are clear. So this is what I just want to cover in the preparation strategy, what you need to focus the areas. Okay. I hope the points are clear. Right. Let me just take you through some questions which are possible to come in your exams, especially related with this communication part. Okay. Few questions, not more, sample questions, just to make you clear with the concepts. Yeah. These model of questions, they are not very complicated. At the same time, they are not very simple, but you can solve within maybe 30-40 seconds, not more than that, if you understand the question clearly, conceptually. Okay. Now see this question, how he framed it. Yeah. If the system has multiple poles on j omega axis, what is the nature of the system? So basically what is the question related with? It is related with signals part. I told fundamentals of signals is very much required. So whenever you are having poles, very simple concept you can apply. If you have the poles located on left half of the S-plane, this is your sigma axis, this is your j omega axis. Now the concept here is related with stability. That is the first point. So whenever you prepare, this concept should come immediately into your mind. Question is related with stability. So your focus should be only on that. Don't rotate in and around. Just think about stability. That is enough. Now, poles are located in the left half of the j omega axis. They can be simple poles, means non-repetitive poles, or they can be repetitive poles, means both the poles coming at same location, or they can be complex conjugate poles. Whatever it is, if they are coming on left half of j omega axis, system is stable. That is a standard statement. Most of the students think that this question is from control systems. It may come under that topic, but stability and causality analysis are particularly related with signals, and this concept will be extended into communication also. So that is the reason I have taken that as a reference. Clear? Now, other than this, what is happening? If you have a system where you are having a first order poles on j omega axis. First order means what? To the power 1. That means there might be a chance that there is a pole at plus j1 and it's a complex conjugate pole at minus j1. And remaining poles, whatever they are, they might be in left half of the j omega axis. Okay. So if they are in the left half of the j omega axis, 100% stable. If at all any poles, the two first order poles on j omega axis, then the system happens to be marginally stable. All poles in left half of the j omega axis perfectly stable. If first order poles located on j omega axis, then it is marginally stable. Over. Now what is the last case? If you are having repetitive poles, the two on j omega axis, means what? It can be a second order pole here, complex conjugate poles which are located at this point. Or there can be any one pole, at least one pole, that is enough, on the right side of j omega axis. Then your system becomes automatically unstable. No doubt. Finish. So what is the question now? The system has multiple poles. Multiple means at least 4, because complex conjugate poles 2 means they should become 4. That means the system will become unstable. Clear? Right. Next. Two systems with impulse responses h1 of t and h2 of t are connected in cascade. Then the overall impulse response is dash. I told you the first part is signals and systems where you can get one question. So this is the area where you can focus on. So you are having impulse response. This impulse response of a system will tell all the properties of your system. Whether your system is causal, whether your system is stable, all these points will be explained very clearly by your system. So that is the reason impulse response of the system plays a very important role in identifying the properties. Now what is he saying? He is saying that one system is there whose impulse response is h1 of t. And there is another system whose impulse response is h2 of t. Now what is he saying? These two systems are actually connected in a cascade. So when you give input to the system x of t, you will get the total output of the system as y of t. Now these two systems are connected in a cascade. So whenever you have a system with input-output equation, overall output of the system is nothing but input of the system convolved with h of t. Star symbol in signals represents convolution. So this is how you can determine the output of a system. X of t convolved with h of t is y of t. Now what is happening? In place of h of t you are having two blocks in cascade or not? That means the overall impulse response of the system should be h1 of t convolved with h2 of t. Now this is the overall system representation. Now for this system you give an input x of t and then you take an output which is y of t. That's all, over. So if you remember this simple technique of finding output for input given to the system based on h of t, you can get this result. So the total output of the system, now what would be your expression? It would be x of t convolved with h of t. So this would be equal to x of t convolved with h1 of t convolved with h2 of t. So either you perform convolution of h1 of t with h2 of t and then perform x of t convolved with the obtained result. Finish. So that is how you can frame the total output. So what would be your right choice? It is not product of h1 of t with h2 of t. It is not some convolution of h1 of t with h2 of t. Correct. So your correct choice will be option C. Finish. So these type of questions by just seeing you can tell. If you just know that input-output equation based on x, h and y, you can directly straight away tell the answer. So this is how you need to understand the concept. So what is convolution and what are the basic models of convolution? So much of models are there, but what are the possible questions that can be given in your exam? Only that particular part you have to cover now. So if you refer to convolution models, so many convolution models are there. I will just tell you one example. Suppose if you take let me take one page. Just a moment. Yeah. Just a moment. This is completed. Yeah. So if you take a convolution model, suppose let me take two signals. I am taking a one step signal which is from -1 to 0. Okay. So this is amplitude 1. Let us assume this is some x1 of t. Okay. I will take another signal whose amplitude is 1 from 0 to 1. This is the second signal, which is x2 of t. Okay. Now, if you want to do the convolution of these two signals, what is the output? So in exam, there is no chance for you to go with the standard procedure. If you go with the standard procedure, at least it will take 3 to 4 minutes. By that time, you can answer 3-4 questions. So standard logics shortcuts are there for these models. So see how I am doing. What is the width of the signal? It is 1. And what is the area of the signal? It is also 1. Width is this part. Area is, this is a rectangle, base into height, 1 into 1. Similarly, width of the second signal is also 1. And area of the second signal is also 1. Clear? That is first immediate identification. Now, only 3 or 4 points. Convolved output y of t exist between sum of lower limits of two signals to sum of upper limits of two signals. So this is one straight point that you need to remember when you do the procedure for convolution. So you should know where is your output coming from. So sum of lower limits means what? First signal is starting at -1, second signal is starting at 0. Those are lower limits. So -1 plus 0 is nothing but -1. Sum of upper limits means what? Where this is ending and where this is ending. This is ending at 0 and this is ending at 1. So sum of upper limits will become 0 plus 1 as 1. That means y of t exists from t equal to -1 seconds to t equal to +1 seconds. So even if you know this point, half of the problem is solved. That is how the questions will be framed in objective papers. Now, next important observation. When you do convolution of signals having equal width, this is having width of 1 unit, that is also having width of 1 unit. So the convolved output is always triangular function. That means the shape of your output signal is triangular function. So you know the shape. Now, from where to where it is existing? You know it is starting at -1. You know it is ending at +1. And what is the shape? It is a triangle. So means it should have a positive ramp from -1 to 0 and a negative ramp from 0 to 1. Finish. You got the convolved out. Over. So this is how, if you know the fundamental points, then these type of questions can be very easily attempted. So he will just ask what is the shape of the convolved output. He will not ask the total output also. So it is a triangular waveform. How you can tell when you do convolution of signals of equal width, the result is triangle. So that is how you can answer the questions in a very quick time if you know these shortcuts. Okay. Next, let me take you to the next question. The Fourier transform of a rectangular pulse of width tau seconds and having unit magnitude is dash. So what is the question here? He is asking Fourier transform of a rectangular pulse of width tau seconds. Means what is the meaning? I am considering a rectangular pulse. Rectangular pulse means a pulse in time domain having a width of tau. Tau means what? it should be from minus tau by 2 to plus tau by 2. So this total width is tau seconds or not? And in this range, he is saying magnitude is 1. So this is your signal x of t. Finish. Is it clear? Now for this function, he is asking transformation. So only important observation here is when your signal is a rectangular function in time, when you have a signal which is a rectangular function in time domain, then if you take its Fourier transform, it will become sinc function in frequency domain. That's all. So this is the standard logic. So what happens now? If you apply Fourier transform for this, then x of f will be equal to, first write a sinc function in frequency domain, means I am writing sinc f. Now that coefficient of f, whatever you write, is this width. What is the total width? Tau. And whatever the coefficient of sinc you have is total area. Area is base into height. Tau into 1 is tau. Finish. Over. So your answer will be tau sinc f into tau. That's all. So this is how you can manage to get the answers in very quick time if you remember these shortcuts. So coefficient of f, whatever I substitute here, is width of time domain signal. And the coefficient of the sinc function which I am substituting here is area of time domain signal. So this is how you can get very quick answers when you get these type of bits. This is also from the signals part. So just to tell you how the questions are getting framed. So these three questions I have taken as a reference that you can expect from the signals part. I told one question can come from the fundamentals of signals. So fundamentals of the signal will include properties of systems like stability and causality. That is the first part. And basic signal transformation. Like we have seen one question for rectangular pulse, the transformation happens to be sinc. So these are all basic signal transformations relating with the properties of the system, this thing. So these are the areas where fundamental questions can be coming from the signals point of view. Okay? So that is the first part that I told you when you are doing the preparation. I told one question you can expect. So this can be from these type of models. Now, this is completely from analog communication. Analog communication means communication analog part. You have two parts, communication analog as well as communication digital. Now this part is covering the analog part of your communication systems. Now what is the data given? In amplitude modulation, dash of the total transmitted power is used for carrying message signal under best conditions. So what is the meaning here? When you refer to amplitude modulation, we have the power given by Pt equal to Pc into 1 plus mu square by 2. So this is a formula to determine the total power taken by the modulated signal. Okay. Now, generally whenever a question is framed in this way without telling about the nature of the signal, the message signal we can assume as a single tone signal, which is like AM cos 2 pi FMT, and the value of the modulation index we can assume mu as 1. These are parameters for amplitude modulation signals. So if you refer to the modulation efficiency, this value is given as mu square by 2 plus mu square. So what is this modulation efficiency giving you? It gives a total power taken by sidebands divided by total power required to transmit the modulated signal. So your question is completely framed on this part. What is he saying? In amplitude modulation means these formulas are valid. Dash of the total transmitted power is used for carrying message signal. under best conditions. So your total transmitted power in denominator, this is the power taken by the message component. So when you substitute mu equal to 1, what is happening? The value of this modulation efficiency becomes 1/3, or in percentage it will be 33.33%. Means what is the meaning? You are giving 1/3 power for transmitting message and remaining 2/3 power is wasted on transmitting carrier. So as per the given data, dash of the total transmitted power is used for carrying message, 1/3 power or 33.33%. So best suitable answer is 33. So that is how you have to tune your mind. Immediately these points should come into your mind. Then automatically you can answer these model of questions. So this comes under analog communication part. And subtopic is standard amplitude modulation. I told you can expect 2 questions from analog communication. It can be from any of the amplitude modulation schemes or frequency modulation or phase modulation. So this is coming from amplitude modulation. So these questions are completely based on formulas. So how we got these formulas, derivations, all these things are not required. So in the initial study phase you may refer to these points, but have a final paper where you are carrying all these formulas. So once you understand these formulas, then easily you can attempt these questions. Just substitute the values, you will get your answer. So that is how you have to prepare for these type of questions. Right. Next. Which modulation scheme uses Hilbert transformer? Now, Hilbert transformation is a concept from signals and systems. So Hilbert transform is having an impulse response h of t given as 1/pi t. Okay, so whenever you have a system, if you give input as x of t, and if you have a system whose impulse response is 1/pi t, then the output of the system is represented as y of t, which is x of t convolved with 1/pi t. So this y of t, whatever you are getting, is expressed as x cap of t. That's all. So this is a fundamental thing you need to know when you are doing this type of question. So this will be covered under fundamentals of signals in the first part which I have told you. So once you know that, your modulated signal of SSB, the standard equation you are having here is AC by 2 m of t multiplied by cos 2 pi fct. It can be minus or it can be plus AC by 2 m cap of t multiplied by sin 2 pi fct. Clear? So m of t represents your message, m cap of t represents Hilbert transformed function of message. So if you have minus here, the meaning is you are doing a transmission of upper sideband. If you have plus here, the meaning is you are doing a transmission of a lower sideband. Finish. That's all. So which modulation scheme uses this Hilbert transform? He is not even asking you what is a modulated signal expression. Which scheme uses this? So only possible answer is SSB. You don't use in DSB, you don't use in phase modulation, you don't use in vestigial sideband modulation. So only modulation scheme we use here is SSB. Is it clear? So this is how, just by seeing you can tell your answer. Fundamental point you require is this modulated signal expression. Next. Now this is a previous topic which I have covered is again on amplitude modulations only, but now it is under previous one is standard AM. This is amplitude modulation schemes only, but related with SSB, single sideband modulation. Okay, sorry. So these are the areas that we need to focus on. Next. Now this is covering a digital communication part. So let us see one question on this area also. Okay. So how questions can be framed from this area, and they have clearly mentioned in the syllabus related with sampling, quantizing, coding. So that means complete formulas related with that particular area. Now see here, a PCM system uses Nyquist sampler. Now what do you mean by Nyquist sampler? The sampling frequency that you are using is a Nyquist frequency, which is twice the maximum frequency of your message signal. That is the meaning. So this is the minimum sampling frequency with which you have to sample a signal so that you can reconstruct your signal without any problem. So that minimum sampling frequency only we call it as Nyquist frequency. So Fs minimum is Fq given as 2 into Fmax. Okay. Now see how he mentioned all the words: Nyquist sampler, then quantizer, followed by a 5-bit binary encoder. So that value of n is 5. So all these 3 points are mentioned in your syllabus also: sampler, quantizer, encoder. So the questions framed also will be in that manner only. Now the bit rate is 50 megabits per second. So RB is a bit rate. 50 mega means what? 10 power 6 bits per second. Okay. Now what is the formula for bit rate? It is always equal to n into Fs. Is it clear or not? Now what is the value of Fs we have taken? 2 into Fmax. That means this value of n is 5 into the value of Fs is 2 into Fmax. Now this value is given to you as 50 into 10 power 6. Got it or not? So from here what you can calculate? You can calculate the maximum frequency of your message signal. What is the maximum frequency? This 10 goes here 5 times. So it will be 5 into 10 power 6 hertz. Or you can also write it as 5 megahertz. Finish. Just getting the unknown quantity, that's all. Now what he is asking, you can see the maximum message bandwidth for which the system operates satisfactorily. So message bandwidth is nothing but maximum frequency of the message signal. So what is your correct answer? 5 megahertz. So it is just by remembering this formula of bitrate n into Fs. That is given, you calculate Fs as 2 into Fmax, you will get Fmax. So all the points which are mentioned in your syllabus: sampling process, quantization process, encoding process, in transmitting binary data, that is related with PCM system. So all this put together, they have asked a question on bitrate. So this is how you have to understand the way to solve the question. So these type of bits don't take more than 30-40 seconds if you remember the formula correctly. So that is how you have to increase your speed and do these questions effectively. So these are the areas that you need to focus when you are dealing with digital systems. Okay. Let me take one more. The Z transform of a sequence. What is the Z transform for this function? So this also is more likely to be from the signals part, but it also comes in our communication area also, digital part especially. So he is asking what is the Z transform for this function u of n minus u of n minus 2. So for u of n, for u of n, the standard Z transformation is 1 by 1 minus Z inverse. And for u of n minus 2, shifted version of step sequence, Z transformation will be Z power minus 2 by 1 minus Z inverse. So if you take the difference of these two sequences in time domain, u of n minus u of n minus 2. Subtracting sequences in time is subtracting their transformations also. Then you will get a 1 minus z power minus 2 by 1 minus Z inverse. So how you can write? This numerator I can write as 1 minus Z inverse into 1 plus Z inverse. This whole is divided by 1 minus Z inverse. So your answer will be 1 plus Z inverse. That's all. So straight away you can tell option D. So this is how the numericals will be framed in your exam. You can do it in a very quick time. Okay. So I have taken a few examples just to make it clear. Particularly related with the communication part, digital question, this is how the model looks like. And these two questions are coming from analog part of your communications. Okay. So expect these type of models which are completely related with formulas. Don't try to study too much and go in depth. Mostly questions will be on formula based only. And signal fundamentals is very much required. Otherwise, you cannot understand all the points. So basic transformations. What is bandwidth, what is power, how are you calculating power for single tone signals, how is bandwidth calculated for message and modulated signals. These points if you remember, then it becomes easier for you to understand the concept. So that is the reason I took few questions from the signals part as well as few questions from the communication part. So these are the areas that you need to focus on. That would be sufficient enough. Okay. So I hope this session is useful for you. Whatever the points that you have to cover, I have told the syllabus very clearly, split the syllabus into smaller parts. All the topics which you need to concentrate, I gave you. Then I told what are the areas that you need to focus and how many questions are probable from each of these areas. So maximum you can expect around 4 to 5 questions from these topics. 1 questions on fundamentals of signals, 2 questions on analog communication part, and 2 questions from the digital communication part. And probable model of questions I have discussed. So these are the areas that you need to focus on. Hope this session is useful for you, and those who are interested, you can contact us, or if you are in Hyderabad, you can come to the academy and talk with our people. They will guide you if you are want to join this particular area only for the communication part, or there can be an online session on this area also. So just inquire it, and if you are interested, you can join. Okay. So focus on this part. Don't waste your time too much. Maximum around 15 to 20 hours should be the time that you need to spend on these areas. Okay. Right. See you and wish you all the best. Thank you.